Hi, this is a demonstrator to show how easy it is to build an AI model to predict server hacks using Jiva's AI platform. So what I've done is I've gone to an open source data repository called Kaggle, and I've managed to find a large data set showing server hacks. We've got about 24,000 rows of data, and as you can see, you've got the incident number, the date, anonymized logging parameters, and finally, was there a hack or not? This is the spreadsheet in question. So what I'll now do is I'll jump to our platform, and how our platform works is via nodes. So I'm going to create a new workflow called cyber security demo. And if I want to do this really fast and not show the nodes, I could easily use one of my templates. But in this case, because I want to showcase the platform, I'm actually going to do it a little bit. I say a little bit slower. It'll still take less than a minute. But I want to showcase the platform, so I'll do it a little bit slower. So I set up a new workflow, and the first thing is to upload the data. So I uploaded that file. You can see I've been building quite a lot of demos and projects in Jiva, but here's my cybersecurity one. Then I'm just going to add it to the workflow. Then the next thing is I want to say, what am I looking for and what are my feature columns? Define inputs and targets. So my feature columns are all of them apart from the incident and the date. So basically all of my logging parameters, and what I'm trying to predict is, was there a malicious offense or not? Brilliant. The next thing I'll do is, there was a lot of rows there, and if you look, I want to get rid of any rows that were incomplete. So I'm just going to put discard incomplete. So that will get rid of any rows that had incomplete data. It's in data science, it's always a good practice to shuffle up your data. So I'm going to be shuffling up my data. And I'm going to do something called a min-max normalizer. And what this one does is it basically brings everything to a 0 to 1 scale. Select all, get rid of malicious events, ID and date. And finally, I'm going to use a type of AI called a gradient boost. There you go, gradient boost classifier. So I'm going to put this feature importance on. I'm going to make my tree 6 deep. And then I'm just going to connect all the nodes. And I'm going to press run. And while it's running, I'll just show you the rest of the platform. So the platform works via nodes, and this time I've uploaded a CSV file, but actually I can get my data from anywhere. So if I've got an API into a software system, if it's an online file, an RSS feed, if it's a website, there's lots of conversions, as you can see, to convert things PDF to table, and it's a generalized AI platform. So what that means is, this is an example of classification, but actually the platform can do regression, NLP, intelligent document processing, large language models. We've got a few of those as well. So it's a generalized agentic AI platform. So this is an example of classification, but just as easily we could have built a regressor or a large language model. And this is the backbone to how you do it. So you can see there's quite a lot of nodes here, and each node does something different with data. So here's something if you wanted to do a financial prediction or scanning from the website. And of course, there's lots of data engineering nodes as well. So if you've got imaging and you need to scale or segment them, you can do that over here. You need to clean up your data from a website, or you want to change some of the language that you're using to build up an NLP model or a large language model. You can do that, all of that over here. AI wise, we've got lots and lots of types of AI. So whether it's a neural network, classification, random forest techniques, different types of regressors, a lot of the backbone is actually being superseded by some AutoML nodes that we've now introduced. So we've got AutoML, which basically buzzes through a whole bunch of classifiers or regressors and then gives you the rundown of which one was the most accurate for your particular problem. I'm going to stop. I'm just going to stop this now and just have a look if my workflow's finished. Oh, brilliant. So you can see it's taken less than a minute. And let's have a look what we managed to do. So in that time, we managed to build an AI model that actually was 100% accurate at predicting whether there was a hack or not. You can see it didn't have such a high specificity when it was predicting no hack, but you get an idea of the art of the possible with this demonstrator. I hope that helps. Thank you very much. If you have any questions, please don't hesitate to reach out.